Hello students, welcome to class 11 physics. In this video we are going to discuss about the average velocity and the instantaneous velocity of chapter 4 motion in a plane. So let us see our first topic, that is the average velocity. Here consider an object P that is moving in a plane. In chapter 3 we had already discussed about the average velocity and the average acceleration and the instantaneous terms, that is the instantaneous velocity and instantaneous acceleration. So average velocity is what? It is the position with respect to time, change in position with respect to time. But that change in position or the displacement is in particular time interval. But in the third chapter we had discussed about the change in position in one dimension, that is either along x-axis or y-axis or the z-axis. But as you can see over here, the object is moving in the xy plane. So as shown in figure, let us consider the object is at P. Initially the object is at O, that is at t is equals to 0. Let us consider object is at O, that is O is considered as the origin and the reference point of the object, and the object is at P. So from this point P, taking the projection on the x-axis will give us the x component, and taking the projection on y-axis will give us the y component. That is, we will be getting the position of the object in terms of the x coordinate and y coordinate. So as you can see, with respect to the origin, the position of the object at point P is r vector, that is the position vector of the object is r vector. So by taking the projections on xy plane, we will be getting the x coordinate and y coordinate, that is the position of the object with respect to x, that is along x axis, and the position of the object along y, that is y axis. And here I cap shows the direction along the x axis, j cap shows the direction along the y axis. So the average velocity v vector of an object is the ratio of the displacement and the corresponding time interval. So here now, instead of taking x for the displacement, we will be taking the displacement as delta r vector. Because we are talking about the average term, we will be taking the delta r vector, that is displacement, and in time interval delta t. So average velocity that we need to denote within this symbol, so it is average velocity v vector equals to delta r vector upon delta t. So delta r vector is nothing but delta xi cap plus delta yj cap upon delta t. Taking this I cap and j cap outside, taking delta x by delta t I cap plus delta y by delta t j cap, we get it as delta x by delta t is nothing but displacement upon time interval along x axis. So it can be considered as the x component of the velocity, so denoting it by Vx, and delta y by delta t, that is nothing but displacement of the object along y axis. So we can consider it as the y component of the velocity, denoting it by Vy. So this equation can be rewritten as Vxi cap plus Vy j cap. Since the average velocity v vector is equals to delta r vector upon delta t, the direction of the average velocity is the same as that of delta r vector, because that we have already seen in chapter 3 that velocity is equals to displacement upon time taken. So whatever the direction of the displacement, that will be the direction of the velocity. So students, you may note down this theory. Explain instantaneous velocity for motion in a plane. So The average term can be converted into instantaneous term when we limit the delta t to 0. That is, the delta t tends to be as small as possible. So taking the limit delta t tends to 0, average term can be converted into the instantaneous term. Suppose the object covers delta r vector displacement in time interval delta t. So the average velocity formula is v vector is equals to delta r vector upon delta t. So this time interval delta t, if we reduce it and make it as small as possible, then we will be getting the velocity at every instant of time, and that is nothing but the instantaneous velocity. So after the times delta t1, delta t2 and delta t3, delta r1 vector, delta r2 vector and delta r3 vector are the displacements of the object in time delta t1, delta t2 and delta t3. As you can see in this figure, initially the position of the object is r vector, that is, the object is at point P. Now taking the object at point P1, then the position of the object will be r1 vector. So displacement over here is denoted by delta r1 vector. Now if we reduce this term, that is, if we reduce this displacement in the time interval delta t2, reducing the time interval delta t2, we will be getting another position of the object, that is p2, and its position vector is considered as r2. Again reducing the time interval, taking it as delta t3, the position of the object will be at p3. So its position vector will be r3 vector, and the displacement will be delta r3 vector. Again reducing the delta t, that is time interval, and taking the position of the object at p only, because here now we are limiting the delta t to 0. So the position of the object is p and its position vector is r vector. So now it can be written as v vector is equals to limit delta t tends to 0 delta r vector upon delta t, that is equals to dr upon dt. The direction of velocity at any point on the path of an object is tangential to the path at that point and is in the direction of the motion. So here we can get the magnitude by dr by dt, that is the formula for the instantaneous velocity, and the direction can be obtained by drawing the tangent from that particular point and in the direction of the motion. The unit for velocity, whether it is the average velocity or the instantaneous velocity, its unit is meter per second, and in CGS system it is centimeter per second. So students, you may note down this theory.